Hello everybody. Today we are going to study BSc first year, second semester and paper 4th geometrical optics. So chapter number 1 is geometrical optics. So the optics is a branch which deals with the properties of light, its nature, its propagation and various phenomena exhibited by it. And optics are divided by into three types. First is geometrical optics, second is physical optics, and third is quantum optics. In geometrical optics, the image formation is formed by the rectilinear propagation. So, what is rectilinear propagation? We know that, and it deals with the phenomena of reflection and refraction. In physical optics, it deals with the study of light of an optical system by interference, diffraction, refraction, and double diffraction, and also wave nature of the light. And in quantum optics, it deals with the particle nature of the light. And various phenomena can be studied considering the particle nature of light as the fiber optics, laser, and concept of matter, etc. Now, in case of a thin lenses, if we consider a lens, the various observation or various distances can be observed through the, suppose this is a lens, suppose this is a lens, the lens, the from this lens, the observation is done from the optical center of a lens. It may be anywhere, but all the observation are done from the optical center. Okay, and in case of a thick lens of a refraction, thin lens of refraction, if suppose this is a thin lens, and in this thin lens and the refraction in this thin lenses, the refraction of the light, the thickness is neglected. In case of calculating the formation of a position and size of a image can be studied by calculating calculating the calculating at the refraction at each surface of a lens, but the method is very tedious. So in 1841, Gauss showed that uh, any number of coaxial lenses. What is coaxial lenses? Coaxial lenses means which have a common principal axis is called as a coaxial lenses. And uh, where we were, yes, showed that uh, it was very tedious that many lenses are applied on it. Then how many observation we get from one lens, two observation from this side and this side. So this method was very tedious. So Gauss showed that any number of thin coaxial lenses can be considered as a single one unit. For this, we can consider the many number of cardinal points. How these cardinal points are considered as without the necessity of a lenses. Coaxial lenses could be treated as a single unit without the necessity of a treating the surface separately. So the lens maker's formula can be applied to the lens maker formula can be applied to the system provided the distance are measured from the two hypothetical lenses with the taking one point as a reference, and the intersection of these planes are considered intersection of this plane points, the points of intersection of this plane with the axis are called as the principal points or principal planes. So, how many types of cardinal points are there? There are six uh, principal points are also called as the Gauss's points. Okay, Gauss point or principal points. So, what are cardinal points? Cardinal points are first are two principal points, two principal points, and second is two focal points. We will see this one by one. Two focal points, and third is two nodal points. Okay, means cardinal points are of six types. Now we will see how what are principal points first. These two principal points and principal planes also are there. Means one is the principal point, and we will see in detail what how are the uh, formation are there, and what are the image space, what is image space and what is object space, and how what is the principal point and what is the principal plane and how they are formed, we will see in detail. Suppose consider one lens here. Okay, and this is a axis. The ray is passing. This is f1. This is f1 point, means this is the focal point. We will study afterwards, after considering after this principal point and principal plane. What we are studying now? Principal point and principal planes. So this is principal point, first principal point, first principal point and plane. Okay. So this point, now we are considering this point. This is the distance between the two lenses. Okay. Now this point is passing. This is passing through the this surface of the lens, first lens. Then after refraction, it bends and then travels parallel to the this axis. Okay. Now, okay. So this is the point S here. This point is This is incident ray, and this is called as a, this side is called as a objects uh, object space, and this is a called as a image space. Okay, now this is passed, and now we are extending the incident ray in a forward direction, and this emergent ray in a direction as well.
कब डालती आज डालती क्या परसों निगाह भी नहीं
So the figure was not coming exact, so that's why I paused the video, and now we will see what are the uh, how the first principal point and principal plane are formed. Now consider this is the axis, and this is f1. This f1 is a first focal point, but when we will study focal point, what is focal point, then we will see in detail focal point. The this point, from this point, this is the incident ray. This is passing through the lens, and after reflection it bends, and then, and after bending it intersects emergent, this is then emergent ray. This emergent ray becomes parallel qw. Here f1s, this ray is passing, this ray is passing f1s, and then after refraction it bends, and uh, emergent ray, this emergent ray pass as a parallel to the axis as a qw. Okay, now what we will do, we will consider this incident ray. This is the incident ray, and this is the distance between the two lenses. What we will do now, this incident ray, we will extend forward in a forward direction. Okay, and this emergent ray will be extended into backward direction. Here, then after extending this ray in a backward direction, emergent ray in a backward direction, and incident ray in a forward direction, where it meets here at this point. Here we will draw an axis, here line. This will be first principal point. Here we will draw, and here it will be first principal plane. So H1P1 is first principal plane, which is perpendicular to the axis and passing through the plane. First principal axis, no, first principal plane. Okay, and P1 is the point of intersection to the axis is called as a, and perpendicular to the plane is called as the first principal point. This is P1 is the first principal point. Now you got it. How the what is the principal point and what is the principal plane. And now we will see how the angles are formed. This angle between the this emergent ray and the extended uh, extended incident ray, the extended incident ray and this emergent ray, the angle between that is delta 1, and the angle between the this extended emergent ray and incident ray, extended incident ray is del. Okay, and this angle, the angle between this both is delta 2, and the angle between this QW and this angle is delta 2. Okay, so the first principal point and first principal plane we have seen, and it was formed in a object space. Okay, the f1 point was f1 was the point we saw. F1s point was incident ray on a plane, on a lens, and the p1 point was in the object space, means the image was formed in a object space in the first principal point we saw just now. Now we will see what is second principal point and second principal plane. In a second principal point, in a and a second and a second principal plane, we will see that these are the two lenses L1 and L2, and the distance between that is D, and here the OA ray, which is parallel to the axis, is incident on the ray, on the lens, sorry, on the lens, and it after refraction it bends, it bends slightly, it bends, and it enters to the this lens as a emergent ray, and then after that it bends and forms the image at f2. Okay, here we form the image as a f2. This is called as the image space. Okay, got it. Here the ray is incident, after refraction it bends, this ray is bending, and after the refraction the emergent ray bends down, and on the axis at point f2 the image is formed at f2 at a image space. We call this as a image space, and this is a object space. So now what is a principal point? The principal point here where the point intersects. How, where and how it intersects we will see. Now we have to do what we have to do. If we extend the incident ray, okay, we extend the incident ray in a forward direction. Incident ray, extending the incident ray in a forward direction, okay, and emergent ray, this emergent ray, this uh, this emergent ray in a backward direction, emergent ray in a backward direction, okay, emergent ray in a backward direction. Here this, okay, where the point, these 2 points, where these two lines meet each other after extending, okay. Once again I will repeat. the incident ray is extended in a forward direction, okay, and the emergent ray is extended in the backward direction, where this both of the rays meet at each other. With that point is called as a principal point. Second principal point, which that is P2 here, and this is the plane which is perpendicular to the axis, which is called as a H2 here. Means H2P2 is H2P2 is second principal plane, second principal plane, okay, and P2 is the point which is perpendicular to the plane, principal plane, and intersects on the axis is called as the second principal point. P2 is the second principal point. Okay. This was the about second principal point and second principal planes.